All right, let's look at the last piece, monotonic. On your sheet it says, a sequence is monotonic if the terms are non-decreasing or non-increasing. That does not mean it's always increasing or always decreasing. It could be increasing and then plateau, and then increase and then plateau, or increase for a while and then stay the same and continue to increase. So, but what thing will never happen is if it's non-decreasing, it will never decrease. But it could stay the same. So 2 important bullet points. To show that a sequence is not monotonic, we simply need to list a few terms and give a counterexample. So let's look at this one. A sub n is cosine of pi times n divided by 2. A sub n would be the cosine of pi over 2, which is 0. A sub 2 would be the cosine of 2 pi over 2, or pi, which is negative 1. So far, my sequence is decreasing. A sub 3 is the cosine of 3 pi over 2, which is 0. Well, now I went from decreasing to increasing, therefore this one is not monotonic. And I've demonstrated that just by listing a few terms. Now, let's list a few terms here and see what's happening. If n is 1, we have 5 plus 1, which is 6. Sorry. A sub 2 is 5 plus a half. A sub 3 is 5 plus a third. A sub 4 is 5 plus 1/4. And what do we notice? We notice that the terms are getting smaller in a very small way. But I can't list them forever. That's not going to prove it. We need to do it in general. So I notice that these are decreasing. So I need to prove that the next term, which would be n plus 1, is going to be smaller than the previous term. If I can show that that's true for all n, then I've proved that it is monotonic. Well, what would be the n plus 1th term? Plug in n plus 1. 5 plus 1 over n plus 1. It's less than 5, the nth term, 5 plus 1 over n. Now I'm going to do some algebra. We can subtract 5 from both sides. 1 over n plus 1 is smaller than 1 over n. You may at this point go, I know it's true for all n. Because if I take 1 divided by a number, and 1 divided by a number just one larger than that, well, this one's going to always be smaller because I'm dividing by something bigger. So you could say at this point, true for all n. If you're not convinced, you could go on, multiply both sides by n and n plus 1. We know that these are positive numbers because a sequence is defined as when n is a positive integer. If we multiply both sides, we get n is less than n plus 1, and we know that's true for all numbers, or you can subtract n and get that 0 is less than 1. That is true for all n. So, our proof is if we had started with this and gone backwards, then we know that's always true. Therefore, this is monotonic. Now, if we start here and we're not able to get a statement that's true, either we did some algebra wrong or maybe it's not monotonic and we haven't looked at enough samples. So for section 9.1, you need to be able to reduce factorials, write an nth term, determine whether a sequence converges or not, and determine if it's monotonic or not. And if it is monotonic, prove it. If it's not monotonic, give some counterexamples.